All right, problem number 1. The question is, are the polygons similar? If they are, write a similarity statement and give the scale factor. All right, so we need for the all the sides, corresponding sides, to have the same ratio. So the two shorter sides on the shape on the left have the same length side, and the longer sides are the same. With the smaller shape, the two shorter sides have the same length, two longer sides have the same length. So if we just do something like long side over short side, all right, in the first shape, we take a 21.6 and we put it over 9, and we see if that's equal to long side over short side, which is 4.68 over 1.8. If that proportion is correct, well, then the shapes are similar. So 9 times 4.68 is 42.12, and 21.6 times 1.8 21.6 times 1.8 is 38.88. So since these cross products are not proportional, are the polygons similar? No. All right, they're not similar. The long side over the short side has to be equal to the long side over the short side. All right, in this case, they will not, so they're not similar. In problem number 2, you're told that the polygons are similar, but not necessarily drawn to scale. Find the value of x, and that's all we got to do here. So if these two shapes are similar to each other, and they don't give us any other similarity statement or anything like that, what we can do is take the long side of the shape on the left and put it over the corresponding shape on the right. So we can do 6 over 59. Set it equal to 3 over the x. Crisscross multiply, so 6 times x is 6x. And that's equal to 59 times 3, which is 177. Divide each side by 6. And we get an x that's equal to 29.5. Problem number 3, in a diagram of a landscape plan, the scale is that 1 centimeter equals 10 feet. All right, so the scale is 1 centimeter equals 10 feet. So our scale is centimeters. Centimeters to feet is equal to 1 to 10. In the diagram, the trees are 4.2 centimeters apart, so that goes in the numerator. How far apart should the actual trees be planted? We're just going to put a variable there. So just crisscross multiply. 1 times x is x. 10 times 4.2 is 42. So how many how far apart should the actual trees be planted. All right, this denominator is in feet, so your answer needs to be in 42 feet. And in problem number 4, scale drawing of the solar system, millimeters to kilometers. So millimeters to kilometers is equal to 1 to 500, which is equal to, for a planet with a diameter of 9,000 kilometers, what should the diameter of the drawing be? So if kilometers is in the denominator, we need to put the 9,000 in the denominator. And then what should the diameter of the drawing be? That's where our variable goes. So again, we crisscross multiply, we get a 500x is equal to 9,000. Divide each side by 500. $18. And again, your 18 was in the numerator, so your answer needs to be in 18 millimeters. Any questions so far? Problem number 5, are the two triangles similar? How do you know? All right, we've got a 39-degree angle congruent to a 39-degree angle. In the middle of this bow tie, we've got a pair of vertical angles. So this angle is equal to this angle. And then this week, we talked about an angle-angle similarity theorem that stated if two angles of one triangle or if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So are the triangles similar? Yes. How do you know? We're going to call it, I'm just going to say AA for angle-angle similarity. All right. One of your multiple choice selections might be the words angle, angle, and similarity, but that's your reason why. All right, problem number 6, state whether the triangles are similar. If so, write a similarity statement and the postulate or theorem you used. Okay, so you've got a little triangle here. You've got the triangle OKJ, and then the big triangle ONM. Now, both of those triangles share angle O. So angle O is the same measure in both triangles. We've got a small triangle with one side that's 3 and another side that's 30. The big triangle, now pay attention here. This isn't a difficult problem, but you got to be careful. We got a big triangle. What's the length of this whole side of the big triangle? Good, it's 4. 3 plus 1. And the length of this side of the big triangle, that's 40. So we're going to write a proportion. We're going to take small side of the small triangle over small side of the big triangle and see if it's equal to the larger side of the small triangle over the longer side of the large triangle, which is 40. All right, so does 3/4 equal 30 over 40? If you cancel out the zeros, 3/4 equals 3/4. 3 times 40 is 120, and 4 times 30 is 120. So the sides are proportional. State whether the triangles are similar, so we're going to go with yes. Write a similarity statement. My similarity statement, I'm going to start with 0.0. I'm going to go down the short side, and then I'm going to go across the unknown side. All right, so I'm going to go OKJ is similar to, in the big triangle, I'm going to go down the short side and across the unknown side. So that's ONM. State the postulate or theorem, and we're going to say OKJ is similar to ONM by, this is side angle side similarity. So side angle side similarity. If a side, the included angle, and another side are proportional, then the triangles are similar. Problem number 7. What is the value of x given PQ is parallel to BC? PQ is parallel to BC. We're going to do the same. We're going to use similar triangles again because angle A is in both triangles. Okay? So we're going to take short side of the little triangle, which is 7, put it over the entire side of the bigger triangle, which is 28. We're going to set it equal to x over x plus 18. All right, so crisscross multiply. 28x is equal to 7 times x plus 18. So our 28x is equal to 7x plus 7 times 18, which is 126. Subtract 7x. So 21x equals 126. And then divide each side by 21. And our x is equal to x equals 6. Just please remember on the big triangle to add the two small pieces together. This is 28. This is x plus 18. Problem number 8, plots of land between two roads are laid out according to the boundary shown. The boundaries between the two roads are parallel. So all of these vertical boundaries are parallel to each other. If all of those are parallel to each other, then all of these small pieces are proportional to each other. What is the length of plot 3 along Cheshire Road? Here's plot 3. Here's Cheshire. So we're looking for this distance from here to here. So we're going to write a proportion. For plot 1, we're going to take Cheshire over Shelby, so 40 over 48. And set it equal to plot 3, Cheshire over Shelby, so x over 56. Crisscross multiply, so 48x is equal to 2240. Divide each side by 48. And we get an x that's equal to 46.67, so 46.7. Maybe I did something wrong there. 40 times 56, 2240, divided by 48. Yep. Problem number 9. What is the value of x to the nearest tenth? All right, again, we've got two triangles. Small triangle on the top, small triangle on the bottom. They have a congruent angle. All right, they both share this angle right in here. These angles are congruent to each other. And they both share this side. All right, if I label this AB, they both share side AB. So that means the triangles are similar to each other. All right. And if that's the case, we can write a proportion to solve for x. So I'm going to take the longer side of the triangle on the top, which is x, put it over this short side of the triangle on the top, which is 8.3. I'm going to set it equal to the longer side of the triangle on the bottom, which is 11.6. And that goes over this shorter piece of the triangle on the bottom, which is 6.7. And then we just crisscross multiply. So x times 6.7 is 6.7x. 8.3 times 11.6, 96.28. Divide each side by 6.7. And our x is equal to 14.4. Problem number, nope, there's only 9. All right, only 9 questions today, this week. So that completes your study guide for quiz 20. Does anybody have any questions? All right, then. Yes.
Could you go back to 7?
Yeah. Please use the rest of the period to work in the ALEKS app or to complete your electronic assignments.